Hello, I'm Dennis Smith, Technical Marketing Manager for Photoelectric Sensors at Banner Engineering. Today I am proud to introduce Banner's new DIN-mountable fiber amplifier, the DF-G1 series. In the next few minutes, I will explain the basic setup and operation of the sensor, and I will highlight several product features and improvements which will make the DF-G1 series a valuable addition to Banner's offering of photoelectric sensors. In addition to excellent sensing stability and updated styling, the most obvious new feature is the bright red and green digital display, which shows the current signal value in red and the switch point threshold in green. Please note that the sensor has been factory trimmed to read 0 counts of signal when no fiber assembly is installed. Opening the dust cover, we find a light operate, dark operate selector switch to control the output logic. An amber output indicator shows when the output is conducting. A 3-position mode selector switch controls the operating mode of the amplifier. The switch is labeled Run, Program, and Adjust. Run mode is used for normal operation after the amplifier has been programmed and adjusted. Run mode prevents accidental changes to the threshold from the rocker button. Only the light operate, dark operate selection switch is active in run mode. Switching the mode button to program changes the display to an intuitive menu providing full control over the sensor configuration. The rocker button is used to navigate and select menu options. The first menu selects the active teach method. The default value is 2-point teach. Also available are dynamic, window set, light set, dark set, and calibration set methods. Next, we can adjust the response speed of the sensor. The default response speed of 500 microseconds includes a crosstalk avoidance algorithm which allows 2 fiber optic assemblies to be used in close proximity. A 2 millisecond and 5 millisecond response time allow for increased sensing range, and a 200 microsecond response time allows for accurate detection of high-speed applications. The offset percentage for the light set, dark set, and window set can be increased from the default value of 10% or by selecting the minimum offset option. The sensor will optimize each application with an offset as close to the sensor's noise floor as possible, resulting in hair trigger switch points in stable sensing environments and larger thresholds in noisy sensing environments. A robust automatic threshold adjustment algorithm can be enabled to compensate for gradual changes in the environment, such as ambient temperature changes or dust buildup on fiber optic assemblies. Next, a full complement of off and on delay timing functions, including one-shots, can be configured. The display readout can be changed to show signal strength and threshold as ADC counts or as a percentage of the last taught value. The display can also be put into an economy mode, which reduces power consumption by 25%. And the display can be inverted to account for mounting orientation. The electronic gain defaults to automatic mode, which selects the best gain with each teach performed. The gain can also be set to one of 8 electrical gain levels. Please note that the signal value is being updated in real time as you adjust the gain levels. Lastly, the sensor can be restored to factory default configuration. Please keep in mind that Banner is able to pre-configure each sensor to your specific needs, making the factory default exactly what the customer requires. Next, we'll slide the switch to adjustment mode. Adjustment mode is used to teach the amplifier and manually adjust the threshold. While in adjustment mode, a downward press on the rocker button initiates the currently selected teach or set method. You no longer have to count button presses when selecting your teach method, nor hold down the button during a dynamic teach. The first button press always starts the selected teach or set, and the second button press completes the selected teach method. Next, I will demonstrate a 2-point teach using a through-beam fiber optic array. The new lever action fiber clamp securely holds the fibers in place. While in adjustment mode, a single press on the rocker button initiates the 2-point teach. The sensor is now displaying the current signal value in red and prompting for the second condition and a second button press. A successful teach displays the word pass and the minimum signal difference seen by the sensor. At this point, we can use the rocker button to manually trim the threshold to a nominal value as required. The blinking 600 indicates that the new threshold has been accepted by the sensor. Finally, returning the mode selection switch to run will prevent inadvertent changes or teaches from occurring. In conclusion, the DF-G1 series is an easy-to-use and powerful fiber sensor. It has excellent thermal stability, a complete range of expert teach and set methods, and it can be paired with hundreds of Banner fiber optic assemblies. Banner Engineering is eager to provide customized versions of this product wherever needed to solve your customers' application requirements. Thank you for your time.